Welcome, everyone. Kubernetes and AI, these are currently very hot topics today. And today, with cloud service provider, we are able to create a Kubernetes cluster and spin up cloud native environments very quickly. And that brings the complexity of troubleshooting and optimizing Kubernetes apps, especially on cloud providers, or whether you have spun up your own clusters within on your on-prem or any third-party cloud. My name is Kumar Baron, and I'll be talking about how to use logging analytics and what logging analytics offers for simplifying the troubleshooting and optimizing Kubernetes applications on OCI with AI. Just some housekeeping forward-looking statements and safe harbor. I'll be showing a bunch of things which are coming up in future, and there is a limited availability program that you may want to join. There are links in the end. So what we'll go through today is uh, to start with, we'll discuss what brings that complexity of managing and troubleshooting Kubernetes, or OKE in that case, where I'll go through the demo also. And what are the different challenges for different people, the platform operators, cloud admins, developers, what observability challenges they face, and how do we solve those observability challenges for Kubernetes in OCI, specifically using logging analytics, monitoring service, as well as management agent. Finally, I'll go through the demo of Kubernetes monitoring solution, which has been created in the last several years in collaboration with a number of customers, and we'll go through the demo. Okay, so what brings complexity in Kubernetes is it takes for OKE less than 5 minutes to create a cluster. So you can create a 10 node or a 50 node or a 200 node cluster within 5 minutes. And that includes yeah, everything from top to bottom, include creating new compute, creating new network, storage, and whatever is inside Kubernetes. When we look at the plain vanilla version of Kubernetes, what it does is it is able to orchestrate your workloads very quickly, providing scaling, high availability. It manages all the physical resources or virtual resources or cloud resources like CPU, memory, storage, and custom resources also. It is of all tracking the states of your custom orchestrators and has its own networking, including DNS and your proxy. So the critical question here is how to continuously ensure the health and performance of these ephemeral workloads. Now, ephemeral is the keyword here because in cloud native environments, the workloads are changing so fast. There are rapid app deployments, very sophisticated CI/CD workflows across multiple components. So for developers, for platform owners, or platform admins, the critical question here is how to ensure the health and performance of these workloads. Now, when we look at that's a plain vanilla version, but when we look at the managed Kubernetes, there are more things. The cloud network, the subnets, load balancers, etc., are also created on top of that. And that is completely managed on the cloud along with the Kubernetes environment. There are operator add-ons, there are service mesh, custom networking, and the control plane itself is managed, which is a joint responsibility of the platform owners as well as the cloud provider. Now, when you're looking at troubleshooting issues, which may come up from any tier of that infrastructure, whether it's the network, compute, storage, or Kubernetes platform, or the application itself. So there are multiple teams and multiple people involved in ensuring the health and performance of this entire cloud native environment. And then depending upon the size of your company or size of your deployment, there are different choices that customers make. You may have a very large cluster, which brings its own benefits, pros and cons, in the sense that if you have a single cluster, you can allocate resources more efficiently across different teams. And on the other side, you can have multiple small clusters, but that brings and which allows some teams to be more agile and spin up and use the resources as they need it. But that also brings the complexity of how to ensure the performance, how to ensure the consistency across these different environments. So consistency in Kubernetes deployment across multiple clouds. Now, that's just one cloud. Now, when you have most customers have on-prem OCI third-party public cloud being used for Kubernetes environment for Kubernetes deployments, and cost becomes a critical factor over here. So it depends upon where you are in the journey of your cloud native migration and transition. You may decide to have few large clusters or one very large cluster or multiple small clusters. But the problem of troubleshooting, optimizing, and managing these Kubernetes environments in cloud native on cloud or on-prem remain the same. So what challenges these different platform owners, or we may say the developers that they face? So there are cloud admins who are managing the cloud, and then we have DevOps engineers who are managing platform and apps, platform as well as the apps. These are ephemeral components, fast changing, complex, and there is a steep learning curve. Now, when we look at these two different teams, the challenges that they face, especially with regards to logs, so cloud admins find it difficult to manage the high volume of the telemetry data. There are logs generated by every tier, every component of the platform, of the infrastructure, of cloud services. Now we have, because it's fast changing and there is a requirement for ensuring that, hey, your CI/CD workflows are efficient enough, there is a requirement for low latency. So how do you ensure that low latency of to gain full observability or end-to-end visibility into what's going on? Reducing alert fatigue and data noise. That's another problem that cloud admins face. They are not just dealing with the Kubernetes environment, they are responsible for all the cloud infrastructure and on across multiple clouds and multiple clusters. Now, on the side of DevOps engineers, where they are managing the platform and apps, they want to ensure that they are tracking these ephemeral, ever-changing workloads, and they're curating the data for correlation across tiers. Now, another responsibility that they have is to how to optimize the resource utilization and fairness of resource allocation across different workloads, across different namespaces, across different teams, and ensuring that building observability or observability is part of their CI/CD pipeline. It should not be an afterthought. And the growing telemetry, increasing complexity of these workloads, it's labor intensive to create a stable and scalable observability pipeline, and obviously the operational cost. So there are different levers or different gears that different businesses, depending upon where they are in their business cycle, that uh, they can tweak. So operational efficiency, which is how to continuously streamline operations and reduce manual effort, basically simplified configurations and centralized monitoring, how to do that. There is a lever for cost efficiency where you may want to look at allocating. So this is in line with how you may want to use a single cluster or multiple small clusters, basically how to reduce cost while maintaining and improving performance. So ensuring auto scaling, resource limit tracking, you have reliability and availability is always one of the goals for any business organization or any business for their IT systems, performance and scalability, how to ensure application perform optimally and scale effectively, and then security and compliance. Now, this is just a guideline here that these are different levers available for different businesses. And depending upon where a specific organization or business in is in their maturity level, or depending upon the time of the year also, there are different requirements in terms of cost efficiency, in terms of security and compliance, and performance and scalability. So your mileage may vary. Some of these levers or some of these gears might be bigger than the others, depending upon where what the priorities of the business are. And that's what essential question here is, uh, that how do we ensure with a single pane of glass view or a single solution that uh, depending upon how the solution, the monitoring solution can tweak or align with your business requirement. And that's where we bring in the Kubernetes monitoring solution, where you can ingest, enrich, analyze, and visualize, act on your telemetry data easily with the agility at scale. Now, what we are offering with the Kubernetes monitoring solution on OCI with logging analytics is we are able to discover your OKE and AWS managed cluster with object chain tracking. So as these ephemeral workloads change, we are able to track the changes in the object state, what parameters changed. So from a platform admin point of view, when there is higher resource allocation or unfair allocation of resources or consumption of resources, the levers you have is, hey, what changed in the requirements for that specific workload? We're doing extensive collection of logs, metrics, and objects with management agent and Fluentd. And this is a fire and forget kind of a solution where once you deploy the solution uh, uh, through the UI or using your command line with by customizing the workflows, customizing the Helm chart based workflows or values. Uh, all the logs and metrics which are generated in future for the future workloads, those are always collected and automatically collected. We provide a live infrastructure platform and application relationship with the topology so that you can visualize how the platform and the infrastructure are related and which components are talking to which other components. There are a number of pre-built log sources for cloud services, your operator OS logs, and common Kubernetes components. We have advanced ML AI based analytics for potential problems, new issues, and trends. And as I was saying, this is continuous log collection. So we are looking at all these different challenges that customers are facing where a growing telemetry volume, we are optimizing that, we are collecting, and all of that is done in a few clicks, and that I'll go through and show in the demo. So drilling down a bit deeper, when we talk about the built-in knowledge for the telemetry sources, we are collecting all the Kubernetes system services, and this is a laundry list of all sort of things, and it may be old. We continuously add new log sources and new logs to the solution automatically. We collect all the system logs, Kubernetes control plane logs, Kubernetes objects, as well as your custom application logs. And all the OCI services logs, the network load balancer, etc., are also collected at the same time. Now, what does it look like when you enable the Kubernetes monitoring solution by discovering by discovering your OKE clusters or AWS clusters, and the enablement is one click. We take care of all the policies. We take care of all the setup and deployment of the Helm charts. And as I was saying, it's future proof. And there is extensive enrichment and live topology view. So this slide on the right that shows the topology view of the cluster where you are looking at the quick summary of hey, these are the different namespaces, what different workloads are available, and where these are running. You get a view of different pods and their current if there are any warning events which are being generated in the cluster, and those are percolated above or percolated up, uh, bubbled up to the corresponding namespaces of workload. What that means is that, hey, if there is a pod which is generating some warning events, it is bubbled up to the corresponding workload, and that is bubbled up to the corresponding namespace, and thus the cluster. So depends upon where you want to start your troubleshooting workflow. You can start from top to bottom, or bottom up, and you get visibility into logs, you get visibility into the metrics which are on the right hand side, and a quick summary on the left hand side. There is a panel which is at the bottom which provide details of the different the events being generated, and there are different views available: cluster, workload, nodes, and pods. Now, this slide shows no difference. The same view, and these are two different clusters, one on OCI, another one on AWS. The same workflow is available for EKS clusters. There is discovery and one click enablement, and all the same set of logs, metrics, and object sets are collected both from OCI and OKE. Now uh, that reduces the complexity or the learning curve that platform admins and cloud admins have to face through by learning where, how to troubleshoot or how to enable that. The workflow that we are providing with the Kubernetes monitoring solution logging analytics remains the same for whether it's on-prem, whether it's OCI, AWS, or any third-party cloud. And we continue to add more and more uh, Kubernetes flavor in our solution. So first view is the platform view where you are looking at the health of the control plane, and we provide you details in terms of logs and metrics for improving the latency of the control plane, how many API requests, what different issues that you are seeing. We are looking at network traffic and configuration of the flow logs for optimization. That you can look at performance and availability of trends for the API server and etcd database. And we'll go through that in the demo in more details. Now, when we drill down at a lower level where this control plane or the workloads are running, that's the compute. We, it's like checking the engine, keeping your Kubernetes running smoothly. So operating system issues and for Linux, for Linux operating system, we are collecting 10, 12 different types of log sources, and there are hundreds of problem labels that are predefined. And problem labels are the ones uh, that identify certain signatures at ingest time and highlight them as at different severities. And for cloud admins, for platform admin, it's important to identify whether an issue which is coming up in a specific application or a pod, it's emanating from the platform issue, or is it because of some operating system issues? Uh, so you may want to correlate OS configuration, the OS such as SE Linux setup, which might be affecting your apps. And also, these compute are the source of or they provide the resources, the CPU, the memory, and the storage layer, and ensuring the health, ensuring the utilization of those resources to manage cost also is also critical. So we provide that view for Kubernetes node monitoring also. Now, when you're looking at telemetry from different tiers, here we are looking at network API response and the API execution time. So all these metrics are available in a single pane of glass view where you can correlate, hey, if the API requests are going up or the network traffic is increasing or packet number of packet loss that is changing, you may want to look at what is happening in the control plane as well as your VCN flow logs or VCN net metrics and compute metrics. So this is important for evaluating trade-offs to reallocate resources in the context of performance and analyze these metrics to across different tiers to assess the impact of what is happening in the cluster. Now, when we look at, as I was saying, this the monitoring or troubleshooting and getting observability should not be an afterthought. And to that end, what we have been doing in the last several months is integrating with the OKE directly, where when you are creating a cluster, or even if you have a cluster already created, you can enable the logging analytics or Kubernetes monitoring solution directly, where you get the visibility of your from your logs, metrics, and traces directly on the OKE cluster details page. So into health and issues, and this is very tightly coupled with the Kubernetes monitoring solution in logging analytics. That's a dedicated solution page where, after looking at some top level metrics or KPIs from on the OKE page, you can punch out into logging analytics. Now it's a one-click enablement as you're creating the cluster in the OKE create cluster or quick cluster workflow. You just click on one checkbox and the same solution, including all sort of policies, service connector, etc. Those are created automatically as you create the cluster, and it's made available in the context of OKE cluster details page within few minutes. Same thing for multi-cloud environment. We have sophisticated dashboards which are available, and the now from the solution where we provide a curated view of different telemetry data as well as the topology. You have the flexibility to create your own dashboards, and there are handful of dashboards which are available, 6 dashboards which are available in Marketplace as well as on GitHub and on certain blogs where you can customize those, you can duplicate those dashboards, as well as this example where we are showing your same cluster or similar type of cluster, one running on AWS, another one on OCI, and they're running same sort of workloads to get visibility. Now, these are all customizable options which are available. We have the common parsers are used to allow comparison as well as to contrast and evaluate your optimal ROI on where the workload should be running, what is happening So ensuring the consistency of the platform, ensuring the consistency of the configuration across multiple cloud that is possible uh, easily with these customizable dashboard. Now, this is all about observability in terms of for the platform admins and your uh, cloud admins, how do they ensure what is happening on the infrastructure side and the platform side? But let's get deeper on those workloads specifically. Now, when developers and the DevOps teams they come in, they are looking at optimizing these workloads, and we provide a very prescriptive workflow over there. Where hey, how do you go about optimizing a workflow? Now, there are issues which might be coming from the code, which might be in the application itself, but during but in the in operations when you are running all these workloads, there are certain levers or certain uh, um, bells and whistles that Kubernetes provides that you have control of. Now, what we recommend there is, hey, start with the topology of the platform itself. Now, this gives you the analysis context in a visual way. You are able to identify the apps and the components which have issues. As I was saying earlier, these issues which are percolated or bubbled up from the specific pod or a specific uh, compute node are bubbled up to the top, and you're able to identify the long-term trends in the performance and new issues or based upon what new things that we see in the logs. And the a common way to troubleshoot these is by tracking historical changes in the configuration. So you start with the topology, and then we have workload insights where what we are able to show is for a specific workload, you get what are the different parameter values currently. And then what is the current state of the workloads? What are the related workloads and relationships with those? Which nodes are they running on? What are the other workloads it's talking to? And where those other workloads are located in what namespaces? So typically in Kubernetes environment, you allocate different namespaces to different teams where they have full control over resources or full control over RBAC and what specific allocation of physical resources is done by the platform admins. Now, new issues are identified from the application logs, and that's what we are seeing on the right hand side in the uh, in the new issues visualization. That hey, we are able to review these changes, what may have come up new or what we have identified as potential issues. Let's drill down into the very uh, a deeper view here. So what you see on the right is, and you may have seen this visualization in Log Explorer if you're using logging analytics, where, hey, we have identified certain new issues and new outliers across in this workload. And now this is very specific to this workload. And if you have created any new problem labels or priority, those those help you identify these issues quickly. And now you can identify new fields for analysis in Log Explorer, as well as you can create these new problem labels right from here once you have identified these new issues. But the next question is that, hey, what caused this change? Now, let's take that aside that, hey, the cause of the issue could be something that changed in the application itself. But there are certain parameters there are in the specification of that Kubernetes manifest that may have changed, and that we are able to identify that, hey, what changed since in the last which labels, which annotations, which mount points, etc., were changed, and that gives an indication of, hey, from last time what changed. These specific parameters changed, and that's one indication of how what the performance or what these new issues could be coming up. All right. So that's the workflow for optimizing applications and for applications drilling deeper based upon logs and identifying long-term trends in performance and what changed in the specification. Now, as I was talking earlier, we have pre-built dashboards, and these have been around uh, for more than 2 years, I believe, and we add more and more dashboards. Also and new widgets also these are available on GitHub as well as in marketplace. and soon will be available out of the box. So you have visibility into Kubernetes nodes where it gives details of the node status, the different how many nodes are there, what pods are running, what their different states are. You have the cluster summary with details of all the different types of workloads which are running, what events are being generated, and the trend of the logs. We have the pod based as well as the workload dashboards, which provide details into the different states, that status of the pods, as well as the different warning events what have been generated in the OKE cluster. And there is a new service dashboard which provide correlation across your infrastructure and the platform view. So basically, if you have Kubernetes services of type load balancer, we are able to link that, hey, this service is exposed to the external world through this load balancer, and you're able to either go from the load balancer into the Kubernetes service or the other way around to identify whether the issue is at the network layer on the Kubernetes service side or on the VCN side or the network side and the load balancer side. So, and this is based upon the metrics, and so the correlation is based upon the metrics and logs that we are collecting into logging analytics and the monitoring service. Now, uh, so what happens when you are when we are collecting and enriching these logs? So there is a guided wizard to get you started. All the heavy lifting is behind the scenes. Now, if some of you may have used the Kubernetes monitoring solution, which was in the marketplace before, and GitHub, now all of that is encapsulated within the add data flow of logging analytics. So whether you click on the compass or go to admin and click on add data, it brings you to this view of where you have different methods of which are for wizard-based collection, which are available to start collecting logs from different sources. Now, one of them is Kubernetes, uh, where you are able to discover automatically OKE and EKS Kubernetes cluster, and we take care of all the policies and dynamic groups under the hood. Now, most of you are experts, and you can choose to just create the scaffolding and customize the Helm charts before deployment, or if you want to make it a part of your CI/CD workflow, the deployment part, you can version manage that and deploy the Helm charts from command line. And as I was saying, all future workloads are monitored automatically. Yes. Okay. Now, under the hood, what happens there is we deploy management agent and Fluentd daemon set through the Helm chart for telemetry collection. Management agent is collecting all Kubernetes metrics and other custom metrics that you may want to collect. And Fluentd daemon set and Fluentd replica set, those are uh, collecting logs as well as the object state and discovery of the platform topology also. Now, all of that, that's not just log collection or object collection which is happening. There is a lot of processing that goes on behind the scene to identify, hey, which workload is running on which namespace and what workload is talking to. So to build that end-to-end topology, all of the telemetry that we're collecting, that is enriched with common metadata to ensure that we are able to provide that end-to-end view, which looks like something like this, that, hey, you have uh, this one-click deployment. In the end, you get visibility into pods, where those pods are running on, what type of workloads these are, and which namespaces, etc. And also ensuring the bubbling up of all the different types of uh, warning events from top to bottom or bottom to top. Now, enough slides. Let me switch gears to all right. So first thing I wanted to show, and as I was saying earlier, there is a limited availability program which is running right now where we have integrated logging analytics into OKE. So before we go into the Kubernetes monitoring solution from here, so uh, this is an OKE cluster that I have running in my tenancy, and from and you this is one of the dashboard which is readily available. And as you get into the details page, you get what the different pod status are, what the node status is, and this is yet another dashboard which is rendered here. Not just that, to enable this, uh, You can do that at the time of creation of the cluster or at the time or even after the fact. So this was done after the fact. And from here, you can punch out into logging analytics to get to this kind of a view. So when you go observability and management, solutions, Kubernetes, and here it discovers. So after you come into solutions Kubernetes, these are the clusters which are being monitored. So there is a cluster in AWS. This is an EKS cluster which is being monitored, and last we heard from it was 3 minutes back. There is uh, a cluster that we created for Cloud World 2024 that is being monitored, and this is the DataGen cluster that I was just showing. And the workflow for enabling or connecting new cluster is clicking on Connect Data, and here it's able to discover all these clusters which are in my tenancy. You select one, go to next page. It will allow you to, hey, do you want to create these policies or not, depending upon whether you have admin privileges or not. And if you have metric server, so these options are available. Now, as I was saying earlier, we can enable the above cluster for monitoring automatically, or you can select to deploy the workloads or helm charts manually from command line in some cases. Now, that's the only option. And what we are asking you is, hey, which compartment do you want to create all the resources, the entities, etc., for this monitoring solution? And once you click configure log collection, it will deploy all these workloads, all these management agent Fluentd workloads on your cluster and get you to this view. Now, from here, once you click on a specific cluster, this is what we get. As I was saying earlier, you have on the left-hand side, we have the topology summary where we see, hey, there are uh, four objects which need attention, 41 which are normal. There are 11 namespaces in my cluster and 30 workloads are running across four different nodes, and there are 65 pods. You have an events panel, which is available here at the bottom, and you can look at warnings only, and it gives you details of hey, what different warnings across different namespaces are being generated. Now, on the right-hand side, we have the telemetry panel, what we call, and this is a scrollable list, and we soon will have ability for you to favorite them and reorganize these as needed. You can expand these to correlate different metrics in the same view. So today we allowed three different types of metrics to be correlated on the same screen. Now you may want to change the time range here to from last 60 minutes, which is the operational view, to 24 hours, and that gives visibility into details across 24 hours. Now, for the OS health, as I was saying earlier, these are logs. These are the issues or issue trends which are coming from the OS logs that we are collecting, and you can drill down into those. There are filters available. These are the different nodes on which this cluster is running, what different problem labels that we have identified out of those hundreds of labels that we have available. And same thing is available for the Kubernetes system logs, where we are identifying issues across different components and core Kubernetes components. Now, when we look at the topology, which is at the center, and the the starting view is based upon, hey, these are the namespaces that we have identified. Now, you can, once you select a certain namespace, let's say I have selected these two, let it load. And that's a typical thing for demos once it loads. Okay, it's back. Okay. So now it started with the namespaces that, hey, you have 11 namespaces, but now I have selected three different namespaces. And what you might have noticed here is that the metrics on the right-hand side, these changed based upon the filter that I have selected. So for the last 24 hours across these three namespaces, the API response size, the total API server request, all the CPU cores allocated, and the memory allocatable memory used, these are based upon the namespaces that I have selected. Now, what we see on the topology right now is that, hey, I have these three different namespaces, and in this specific Flux system namespace, these are the five different workloads which are running, and the issue is coming up from on this workload, and this is a specific pod on from which the issue is coming. Now, when you're looking at a specific pod or a specific workload, you can right click on on the node as to visualize the logs. In this case, because this issue has been occurring for quite some time, we have not identified any new issues here because these were existing beforehand. But for new issues that are coming up, we identified the new issues and outliers and only show those. Now you have the flexibility of going into Log Explorer to troubleshoot this and drill down deeper into those. So this is the topology view. This is the cluster view we have available. Now let's go into the workload view. And as you may have noticed, along with the namespaces, we have workloads. So I had selected three different namespaces as it says on the uh, summary panel. And in across these three different namespaces, these are the workloads and of type deployment which are running here, right? We have all of these deployments uh, here, and the details are available. And this is how long they have been running. That looks like quite long. And based upon the selection you may have, so for example, if I select just one workload, the metrics on the right hand side are also filtered based upon that. So right now, I'm seeing the metrics only for this cert manager workload, which is running. Now, if I want to further narrow down so it's running on one specific node. So in this case, it won't change. But let's say, I guess it was running on a single node itself. But yeah, okay. In this case, it's running on, so these two workloads are running on two different nodes, and I'm now able to select a specific node and get to those metrics. So now I'm looking at the metrics coming from this specific on from the workloads which are running on this specific node 10, 0, 10, 190. Now let's go into the node level view where you can look into details of your specific node. Now, in this case, I have selected this. Let me remove that. This. Okay. Something wrong with my browser today. Okay, so now we are looking at all the four nodes and what their different configuration are, what their current state are, if they are seeing any issues, and how long, what was the last reported status of those, what the configuration currently is. And at this point of time, we are looking now, since I've removed all the filters, I'm looking at metrics which are coming from all these nodes across all the workloads. And finally, we have the pod view where you see details of specific pods. Now, if I'm going to select a specific namespace or a workload, it will drill down into those specific pods, but I can look at one pod and see, hey, what the controller is, what the type of that controller is. In this case, this is a replica set, and default scheduler is being used, and on which node it is running. Now I can narrow down either by namespace or look at these specific pods from here. And you may have noticed also that the grouping of the pods also changes depending upon which view you are in. So this is by node, this is by workload, and in the cluster view, you have it by namespace. So this is the end-to-end Kubernetes monitoring solution that is available uh, in logging analytics today, starting from your discovery to enablement to customization to this end-to-end workflow. Now, you have the ability to drill down and go into logging analytics or Log Explorer to look at all these logs. and the all the logs are have the metadata associated coming from the Kubernetes. So for example, so these are different fields which are attached to all the logs that are coming into or that we are collecting. So the top one is the Kubernetes cluster name. Here we are looking at the, so if you notice, these are the same cluster names or that we saw in the Kubernetes solution. Now I can select one and just look at, so these are the different types of logs as I was showing in my slides, start from Linux logs, from Kubernetes system logs, to application and uh, pod logs also. Now, all the application logs or pod logs are collected against this Kubernetes container generate logs. And when you look at this, now what we recommend from here is to create custom log sources or customize these based upon either you can attach an annotation to your pod which tells the Kubernetes monitoring solution, hey, this is an Nginx ingress controller or some other application pod or uh, for which you have created a log source or a parser directly. But the way to start with this is when you start with so there is the pod name, which is attached to all the logs. So you can narrow down based upon this. Or other way to do that will be to use the cluster, the AI capability that we have, which will help you group the logs based upon the shape that they have. And based upon that, you can start creating your new problem labels as well as parsers directly from within Log Explorer. Now, there are dashboards which are available. So So these are the five different dashboards as I was talking about earlier. So these are available on GitHub as well as in the marketplace where where we recommend getting it from GitHub, and these will be available out of the box in coming weeks. And you can fully customize these by duplicating these or creating a new dashboard and making and selecting. Uh, Widgets from different dashboards into your own. And as always, these are you can punch out into logging analytics and drill down into this. All right. So we looked at different observability challenges across different teams becoming because of the ephemeral nature of Kubernetes, how these fast changing environments are being managed, and uh, how they generate the vast amount of data due to these components, due to the sheer volume of logs and logs, metrics, and traces, which can be overwhelming and very difficult to manage. And this can lead to difficulties in identifying relevant data, right? And delays in detecting issues and increased cost for storage as well as processing of monitoring data. Now, we looked at different levers which are available for you, depending upon where you are in your business maturity cycle, whether it's operational efficiency, which is important to you right now, performance and scalability. What we saw in the solution is we provide the logs, metrics, object states, as well as topology for all the teams to start uh, looking at uh, Kubernetes, what's happening in your OKE or any Kubernetes environment to start with. And we are handling all of these challenges that cloud admins and DevOps engineers face in a simplified way, starting from easy deployment, discovery to continuous monitoring of these workloads and including your infrastructure as well as the platform. Now, what are the must-haves for these Kubernetes monitoring solution that we have seen that we have learned from our customers, some of our largest customers like 8x8, where the performance issues must be resolved quickly for business growth, and it's important that root causes are identified to avoid future incidents. And each and every team who is responsible for managing either the infrastructure, the cloud services, platform applications, they should have an ease of use. They should provide provided easy to use observability tools instead of learning about the observability and tools themselves. There should be an easy curated way that they should get to start troubleshooting and identifying these. As such, the business workflows and the business applications are complex in themselves. So we don't want to bring that additional complexity into the observability workflows. So, and as I was saying earlier, we have a limited availability program for the OKE integration where you can enable logging analytics directly from the OKE cluster details page or at the time of cluster creation that is available right now. And if you want to participate in that limited availability program for early access, just go to this link and we'll get in touch with you. So thank you so much for joining us today.
If we don't have any more questions, I just want to thank you for your time and attendance in today's session. I can conclude the call. Have a great rest of your day and great session, Kumar.